Welcome. Let's solve Leetcode 3264, final array state after k multiplication operations 1. We're given an integer array nums, an integer k, and an integer multiplier. We're allowed to perform k operations, or we need to perform k operations on nums. Find the minimum value x in nums. If there are multiple occurrences of the minimum value, select the one that appears first. Replace the selected value x with the x multiplier, and return an integer array denoting the final state of nums after performing all k operations. Okay, so let's walk through this first example here. This is the original list of numbers that they give us. K is 5, so we must perform 5 operations, and the multiplier they give us is 2. Looking at this input here, after one operation, we multiply this 1, which happens to be the minimum, and we replace that with 2. And looking at this new list now, the minimum is 2, and they tell us if there's a tie to use the first one. So we exchange that with 2 times 2, which is 4. Looking at this list now, the smallest value is 2. We multiply that by 2 and exchange it, 4. Looking at this new list here, minimum value is 3. We change that with 6. Looking at this list here, the smallest value is 4, and we change it with 8. And we would return this. And that's it. There isn't much else to the problem. So what we'll be using is a heap to store the smallest value. And when we use the heap, we'll also store the index. So we know where that minimum value is located, so we can use it to update the value with the multiplier. Okay, so let's I think that's enough to get started, so let's begin. I think I'll just walk through it quickly, although we could probably start coding it right away. What we'll do is we'll make a heap. So what we'll do is we'll make a heap. So first we need to format the heap. So let's see what we want to do. So for all numbers, we want to store the number and its index. So we'll loop through this list of numbers they provide us, and we'll store that number and the index. And yes, and we will store this in a min heap, a minimum heap. So this min heap is an excellent data structure that helps us locate the minimum value in a collection in constant time. So we don't need to, for example, we wouldn't need to loop through the array every time to find the smallest. We wouldn't need to do that. So the heap will assist us in doing that quicker. Next, what we'll want to do is, so for k, do this k times. So remember, we want to so we'll remove the minimum. But what we'll do also, though, remember, when we remove the minimum, we'll have that number, the min number, and we'll also have that index, whereas index of min number from Q, or min heap. We'll just call it min heap. So as many times as we have, or we're allowed or told to do it, in this case, for this first example, we were told 5 times. What we'll do is our heap will store all of the values and their index. And what we'll do is k times we'll remove the number and we'll remove the index. And then we'll update our list our list and update our list with this new number with the min number times multiplier. Remember that? Remember that? Multiplier. And then we'll put it back on the min heap. Put min number times multiplier back on min heap. Because remember, we may need to use it again. So remember, like for example, in this case, this was 2, it was 4, and then we changed it to 8 again. So we may need to use it again. So that's why we need to put it back on the heap. And after that, well, we'll be done. We can just return our list. Return our list. Okay. And I think that's it. It should become clear if it isn't clear now when we code it up. Okay, so let's do it. Okay, so let's make a queue, and the queue will store the format we need. So the format we need is we need the number and the index. So what we'll do is we'll say, okay, equals. So let me see, for I n in enumerate n, and then we'll say we'll store that number and the index. Okay, and then we'll heapify q. Okay, let's print out how q looks, just for the hell of it. I might throw an error because good. So remember, our list looks something like, well, so it looks like this here. So 2, 1, 3, 5, 6. So 2 is at index 0. 1 is at index 1. Let's see, make this higher. Yes. So 2 is at index 0. 3 is at index 2. 6 is at index 4. So that's what it looks like afterwards. And then, okay, so our queue is ready for work. So then we'll say for in range k. So we don't really need the index of k. That's not really important. I know at the end we'll return n. So what do we need to do here? We need a heap pop from q. And what will it return? It will return the number and the index. So we'll just call this, I don't know, n and I. And what we want to do is we want to update our list with the number times the multiplier. So in our original list, which is n, at the index, we want to change this with 2, no, sorry, not 2, the multiplier is m. So n times m. And then we put that value back on the heap because we may need to use it again. So so heap push onto q. So we want to do the same thing that we did up here. So we want to plug in the new number times the multiplier and the same index. And I think that should be it. There shouldn't be anything else. I think we can just run it now. I will provide a maybe slight optimization that may be helpful, but let's see how this looks first. Okay, well, it's already pretty good. Well, I still want to show it to you anyway. If you watched any of my other videos, you may have noticed that. So notice k. K could be, how big could k be? K could be, well, 10. That's not too many. All right, well, you can probably stop watching this video now, but I still think this is worthy enough to go over. Suppose k was like something like 1,000,000 or 1,000,000,000. So that means you would be doing this operation and this operation 2 times. So that would be 2 billion or 2 million. What I'm suggesting or recommending is maybe we can just do it with 1. So one of the properties of the heap is that the first index always stores the minimum, depending on if it's a min heap or a max heap. But in this case, it's a min heap, so the minimum. So we don't need to pop it off. But now, though, we'll need to modify this a little bit because we still need to remove this from the heap. But I'm going to use a different method, and this one's called heap replace. So this will remove the minimum element and put a new element on in one operation. So it's a little bit more efficient. So let's see what happens here. This is good. This is good. So we don't need to change anything here. And then we replace, yes, n times n times i. N times m and the index I. Let's check it. I think this should work just fine though. Okay, let's run it, or let's submit it. Now, because our original submission was already fast, there isn't much difference. Okay, that's it for this problem. It was not too bad. I mean, once you understand that we can leverage the power of a heap to make our work easier and more efficient. So if you found this in any way beneficial or helpful, please consider liking or subscribing. Have a wonderful day. Take care of yourself.